So yes, let's draw a BST, right? Let's draw a BST, and I am giving you that 5 is there, right? And let us suppose you are having 4, then afterwards you have straight away 1, you are having 2, correct? And then what you are required to do afterwards? Suppose that you are having 8 here and here you are having 7, correct? Now, let me ask you that if suppose, let me just write the topic here, it is deletion in BST. Now, if I ask you for one thing, suppose this is the BST that I'm dealing with, right? Delete any of the leaf nodes 2 and 7. Then how the overall BST should be looking like? What are your thoughts?
Delete the leaf nodes 2 and 7, right?
Yeah.
Yeah. 5. Root element is 5. And
Okay, either 2 or 7 gets deleted, right? I think this
yeah.
is the only edge that would be cut off. Am I correct?
Yeah,
If you
yeah.
try deleting any of the leaf nodes, right? Then straight away their edges would be cut off and the remaining structure remains as it is. Am I correct onto that part?
Yes.
Okay, so if I delete leaf node, there's not going to be any kind of problems that I'm going to face. If suppose 2 is getting deleted, the major change structurally that I'm going to get is whoever is the parent of 2, that is 1, right? Its right child would be now pointing to null, right? Is it that? I have to make that, okay, previously once right child was pointing to the node 2, now after the deletion, it should be pointing to somewhere called as null. Am I correct onto that part?
Yes, yes, right.
Okay, then similarly for 7, if you delete this particular leaf node, now 8's left child would be pointing to null. I have to just update the address of the left child or the right child if the left or right child are leaf nodes. And correspondingly, whatever their parents are, now their corresponding child nodes would be pointing to null. This is what I'm going to do. Okay. Fine then. Then what else are the scenarios? Let's see that, right? Let's see that. Okay, now if I ask you, suppose one of the nodes you are trying to delete in BST, 5 is there again, let's take it. Let there be 3 here, then let there be 2 here, right? And sorry, 2 won't be here, right? So let's suppose you are having 4 here. And afterwards, from 4 again, yeah, let us just. So I say that from 3, 1 is attached, right? And afterwards, suppose 2 is attached with 1. That's what is the structural nature of my BST. And from here, suppose you are having 8 again, and with 8, suppose 9 is getting attached, right? 9 is there, that is getting attached. Now, let me know for one thing that if you try deleting either this 1 or either this 8, then how the overall structure should be looking like corresponding to that of the BST.
2 will be the left of 3.
Okay, now one thing is that, see, whatever node I am deleting, right, it has just one child node. Is it that?
Yeah.
That is just one single child node. Correct?
Yes.
So what would happen is, if I try deleting this, I have to just do one thing. 2 resides in the left subtree of 3. Correct? Due to the presence of 1, 2 is residing as the right child of 1. Now, if 1 gets deleted, I can safely attach this 2 as the left child of 3. It's still structurally correct. Am I correct as per the nature of BST?
Yes, yes, you're right.
Okay. Now, suppose you delete 8 as well, right? Again, 9 greater than 5. So I can attach 9 straight away as the
Right side.
what? Right child of 5. That these part can be done. So 2 scenarios we have seen so far. What is it? If you are deleting any of the leaf nodes, whoever are their parents, update their left or the right child, right? To null address. If suppose a particular node I am deleting, whose exactly one of the child node exists, either the righter or the lefter. So whoever is the parent of one, right, just pass on them that their lefter child from now onwards would be the corresponding single child node with which this particular deleted node was attached with. Fine. These are the two straightforward scenarios. You are trying to delete that particular node correspondingly, which has just a single child. That's what, and or that does not have any child node at all. So accordingly, how their parents would be updated. In the first scenario, the parent would be whatever was their child node as the leaf node was present. Now that particular child node would be made to null. And here I would be straight away passing on that 3's lefter child or 8's or 5's writer child from now onwards would be the single child node's address with whatever the deleted node was attached with. Correct? Now the real scenario comes into the picture. Suppose that right now you are trying to delete that particular node which has all kind of possible child nodes. Then what's going to happen? 5 is there, right? Then 3 is there. Then suppose again 1 is there. Afterwards, 3 is connected to 4 as well. Correct? Then I can say that afterwards with 5, suppose that 9 is there. And with 9, 7 is attached, 8 is attached. This is the kind of BST we are, sorry. It's not going to be 8, it's going to be 10 suppose. Now tell me for one thing that if you are trying to delete this 3, what ideally should happen?
Writer node of the 3 is joined to 5. Like 5, 4, 1.
Yeah, that can be done, right? That can be done. Either I can shift my 1 to this 3 or either I can shift my 4 to this 3. Anything works in that case. Tell me that works.
Yeah, anything works.
Okay, so if I just say, let's change the scenario. It's quite a bit simpler thing, right? What if I say right now, this is going to be 2 for me and let there be a 3 that is present somehow like this. Now what you're going to do? You have to delete the node 2, suppose.
One will be changed their position.
Okay, no, but just go for a generalized approach right now. Okay, fine. That can be done, right? 1 can be shifted to this 2. But algorithm, I have to just make it in general. It's not that I can say for few scenarios, you shift your left child, which does not have any further left or right child, to this particular node slot, whatever is getting deleted. And in some cases, you straight away shift 4 or 3 at this particular position. Think in general, what I can try doing. In case of suppose you are saying that 1, shift 1 to the place of 2. That's quite valid. That's very good approach. And in some cases, I say that when 3 was not there, suppose shift 4, the next occurring node in the in-order traversal of my entire BST to the position of 2. This is what you are trying to do basically. This is what you were suggesting, right?
Yeah.
Okay, then what are 1 and 4 called? Can you let me know on this? What are 1 and 4 called? You are saying that whatever node in terms of value occurs just before 2, shift that to the position of 2. And whatever nodes come just after 2, just shift that to the position of 2. Either of the approach works in our case in order for deletion, right? What are they called? See, this node is what you call as in-order predecessor. In-order predecessor. Getting it? Similarly, this particular node 4 is what you call as in-order successor. Works.
Yeah.
Okay, so what you are required to do, if suppose a node is there whose lefter subtree is also existing, righter subtree is also existing, right? Because the left and right child both are present. In such cases, either you can take your in-order successor to the place of the deleted node, or you can take your in-order predecessor in the place of node. So let's take the approach where I'm going to be saying that whoever is going to be the in-order successor, this such kind of nodes which has both lefter and righter subtrees, I'm going to place that in-order successor in the position of the node. That's what I may try doing, right? That's what I may try doing. So let's try this. Let me write it somewhere else. 5 is there, then afterwards let there be 2, and 2 afterwards 4 comes, then 3 is coming, then I'm going to be saying 1, and let there be 9, and let there be 8 or 7 or 10, let us suppose, something like this. So you are trying to delete the node 2, am I correct? You are trying to delete the node 2. Now what should how should I proceed ahead? Tell me. How should I proceed ahead? I said that take the path of in-order successor.
Yeah. The 4 goes to 2.
So 4 is not the in-order successor. Which is the in-order successor right now? 3. Am I correct?
Yeah.
In-order successors. If you take the in-order traversal, 1 comes, then 2 comes, then 3, 4, then 5, 8, 9, 10. These are the nodes for us. Is it that?
Yeah.
Is it that? So these are the nodes for us. Okay then. So 3 should be taking the place wherever 2 is existing. That's what we might try doing. Okay, so if I am located, I know that I have located the node 2, what needs to be deleted. If suppose you are standing here, You have already located the node wherever the deletion needs to be performed. Then from here onwards, I need to check which is the in order successor of 2. Then how you are going to go ahead?
3 moves to 2, right?
Yeah, so you have to locate, right? If you are at 2, you want to delete this node, you have to first locate where is the in order successor of 2. You have to first locate that. Then what you are going to do? See,
Check the
it is
minimum difference.
in order successor is always into the writer subtree of 2. Agree with me? In order successor is always in the writer subtree of 2. Agree with me? It's
Yeah.
successor, node occurring afterwards. What kind of node it would be? The smallest node possible into the writer subtree of 2. Can I say that?
Yes.
Can I say that? Suppose that you are having node n and it has a writer subtree that starts off from its right child RC, right? Then suppose it has multiple other nodes. X is connected, then Y, then Z. Suppose X is further connected to A, RC is having further more number of nodes B and C and so on, right? Now, you want to delete this particular node and it has also a lefter subtree as well, right? Now tell me for one thing that you want to delete this node and you have to locate its in order successor corresponding to the writer subtree of n. What you are going to do in that case?
Z will replace N because Z is the lowest in order successor.
Yeah, my point is how you're going to locate that, where the Z is located. Lowest particular node possible into the writer subtree of n. See,
Leaf node of
I can just straight away say I have to start locating the in order successor from the right child of node n, right?
yeah.
That's the main thing for me. Now, what else needs to be done here? If you start off the traversal from the right child, keep on going to
Goes
the
left
left.
side left. Keep moving left. Left
Yeah,
of the
keep on going to the left. Suppose there is a position where no more lefter position is available. Then this is gonna be my in order successor. From the right child I started, it's lefter child. Okay, it further has a lefter child, further smaller node. Go to Y. It has further lefter child. So go to Z, and here whenever I strike, no further lefter child exists. Correct? That means this is the point which is the smallest node of the entire subtree that started off from the right child of node n. I can just straight away return the value. I can straight away return the value and I can just copy it in the position of n. Works. I can copy it in the position of n. Now, what's going to happen next? Corresponding to this subtree, I found the position of Z, the in order successor of node n, and afterwards, I just copy its value in the position of node n. Then afterwards, what you are required to do?
We replace the Z to null.
Exactly. We will just delete the Z, the node Z. Now I can say once the value of Z has been utilized, this node is no longer required. Just delete this.
Yeah.
Okay, because practically this node has moved on to the position of the node wherever the deletion was to be performed. So I can just try deleting this node, whatever it is. That's it. That's it. So what's going to happen is corresponding to the current example, whatever we are taking, you want to delete this node to fine. Now from here, its in order successor is required. So I'm going to jump on to its writer subtree that starts off from 4. Then what would happen next? 4 has a further lefter child 3. At this particular position, right? No further lefter child exists. It's null. So I know that this is going to be the smallest node corresponding to the subtree that started off from 4. So return its value. Just grab that and return the value. Copy that to the node. Whatever was supposed to be deleted. Now the node here is 3. Then I would be straight away going ahead recursively and I would be saying that delete this node 3 further. It's no longer required. Okay. Is it clear for all of you? Tell me that.
Yeah.
So what's going to happen here? What's going to happen? Whatever is the in order successor, try finding it and just place this particular node in the position of the node what is supposed to be deleted. That's it. If suppose this is the case where corresponding to the node, both lefter subtree and writer subtree exist. Okay. Previous cases where if suppose no lefter subtree is there is writer subtree but no lefter subtree. Just attach the writer subtree right to the parent of the node that needs to be deleted. If there is a lefter subtree, then straight away attach the lefter subtree to the parent of the node that needs to be getting deleted. And if suppose the node that you are trying to delete, it does not have any lefter or writer subtrees, straight away just attach its parent's writer or lefter child to null. That's it. So 3 cases we need to handle here. All fine? Tell me that. All fine? Can we try going ahead with this? Is the approach clear for you?
Yeah, it's clear. Go ahead.
Let's try delete in BST. Okay, let's take here because I think the UI of your, what should I say? UI of your lead code is quite bad running these days. Delete the node from BST here, right? Let's try from here. Okay, so let's take the Java program. Yeah. Tell me what we can try doing first. Firstly, you have to locate the node. Our first thing is I am to locate the node what needs to be deleted. Am I correct?
Yes.
Is it that I'm gonna do? So what needs to happen? Let me just see. Okay, if no node. Also, there is a corner case. If there is no node with value X, right, then do not make any change. So this is typically the position that if suppose I have reached a position corresponding to all the searchings that I have done, there is no node whose value is equal to that of X. You have reached a position that is right now rooted at null. Then what I'm going to do in that case? What I mean to say is that you started off with certain root of the tree, right? You keep on searching for the left child, suppose, and at the end, no particular node matched. At whatever node n I'm standing right now, right? That's value is equal to that of null. So I can straight away return from here. Am I correct? Return the value of the root. Can I do that?
Yeah.
That this is the thing, or typically this is the scenario where your entire subtree becomes empty. There is nothing to delete, and straight away return the root. So if root becomes equal to that of null, right? Straight away return the value of the root. What else I may try doing? Let me know.
Then find the
You have to
node
first
which
locate the node. First thing, locate the node what needs to be deleted. Then what you are gonna do in that case? If root,
that value equal to X.
okay, first let us handle if the root dot val is greater than X. All the cases where we actually need to make recursive calls. First handle them. Then what I require to do? Delete the node, right?
Yeah.
Uh, okay, perform the deletion on what? And I think it should be returning some value, right? It should be returning some node address post the deletion. Then what would happen? Tell me that. So if suppose I'm standing at a root value, what are the I'm standing at the root and the root's value is greater than that of X. Then what you are going to do? I need to perform deletion on its left subtree. Tell me that. Is it the scenario?
Yes. Yes.
Okay, so suppose the current root's left child may be affected. You agree with me? Maybe it may be possible that the immediate left child of the root would be deleted. Right? So right now, instead of the left child's address, some new address is gonna come up. Should I reset the value of the left child of root after the deletion has happened? What are your thoughts on to that? Root's value is greater than X. The into the left subtree, some deletion needs to happen, right? So it might be that roots. Where is there, by the way? Yeah, roots left. How to close it, by the way?
Oh, line number 1.
Okay, yeah. So I can just say here, right? One thing that root's left child, maybe the root's left child might be switched on to null. Its left child was the leaf node, whatever I was trying to delete. So it might change. So it's better for me that keep on updating the root's left child if the deletion is going ahead into the left subtree of my current. So root's left child would be that particular node whose address is getting returned after the deletion has happened. So I can just say root left would be equal to that of delete node into that I am performing into the root's left child and corresponding to the node X. Fine. What else I require to do? Tell me that. What else I'm required to do? After the deletion has been performed. Yeah. root dot val. If it is lesser than x, then the deletion would be performed in the writer subtree. It might be distorted.
Yeah.
It might be distorted. So you just say roots right equal to that of into the writer subtree if I perform the deletion. Yeah. Then what
It's
else?
not root dot value, it's root dot data.
Okay. They are utilizing data, I feel. Yeah, true. Val is in the lead code, whatever they utilize. Yeah, fine.
After
Okay.
that, we check if root dot value equal to x. If find the node.
Yeah, so I think if and else if, let that be an else if, either the value can be equal, can be lesser, can be greater, right? And at the end, there is an else condition. What if the root dot data is equal to that of x? Currently, this is the node that we wish to delete, right? Then what you are going to do next? Then what you are going to do next? Current node is to be deleted. Three conditions now. Three conditions needs to be handled. How would you handle this?
If root dot right not equal to null.
Okay, so if suppose current root is corresponding to the node, what is getting deleted? If root dot left is equal to that of null and root dot right, if that is equal to that of null, right? Then I'm going to be saying return what? Return what? This node would be deleted. So instead of this node, its parent should be receiving null address. Agree with me?
Yeah.
Its parent was to be reset with its left or right child's address after the deletion. Correct? So I'm going to be saying that if this node gets deleted, its address should be returned as null. Straightforward. Okay. Else if. Else if. Tell me, what would happen next? Else if. Both are not null for us, right? Both are not null for sure. Either there may be scenario that root dot left. Then what? How you are going to handle the case? Second case. First case is both. This is the
root dot. Yeah, root dot right equal to null. If root dot right equal to null, we can return root dot left.
Yeah, else if root dot right equal to that of null, then straight away just return what? Root dot left.
Root dot left.
Okay, else if there can be yet another scenario, root dot. Now what? Root dot left
equal
to that of null. Then just straight away return the address of root dot right. Is it that? Okay, now suppose none of them is null. The current node, what is to be deleted, right? That is actually having both left and right sub.
Yeah.
Then what?
Find the in order successor.
Okay, so let's write the code for it. The in order successor. Public static, and it has to be returned some sort of node and in order. In order successor, right?
Yeah.
And here it takes what? Some node value. What is it, by the way?
Node value.
Node. Let that be root only from wherever I have. We are trying to locate this. Okay, how you are going to proceed ahead with that?
If root equal to null, return null.
If no, that's not required. I feel there must be a root's address. Then only we would be able to locate the in order successor. Works. Can I just say if root
that left equal to null, return root?
Yeah, if root dot left equal to that of null, definitely return root. That's gonna be my in order successor. Else, return the in order successor
of root dot left.
Yeah, into the left or subtree. Further, if any in order successor is possible, just return that.
Yeah.
Root dot left. That's what we have tried doing. Okay, what else? This part is done, so I have to first else, right? This further has an else condition. Even if we don't take it, I don't think any problem is gonna be there. Okay, what should we do here? In order, right? In order successor. This is what we are requiring. So let me name that as successor. Successor would be equal to that of, I would call the in order. It's gonna be the function call. Just a moment. In order successor that starts off from my current root's right child. Is it that?
Yeah.
Pass it on, and whatever successor you're getting, just make it as it is, right? Then how you're gonna do ahead? Tell me. Then what you are gonna do ahead? Successor you have got. Then what would happen afterwards?
First,
Node dot whatever node I am having or whatever root I'm standing at, root dot data would be equal to that of successor dot data. Can I just straight away do this? Copy the data. Nothing else needs to be done if I'm not wrong. Okay. Then what else I am required to say? Okay, the data has been copied. Now delete the successor wherever is it present. Am I correct?
Yeah.
So what you are going to do in that case?
Successor equal to null, right?
So can I just say whatever is my root, its writer subtree may be getting distorted, right? Root dot write would be equal to that of delete node. Delete node. Again, same deletion we are performing, right? So same recursive approach I can try it. Delete node and give your root's writer child's address, that from the writer child onwards find this particular node whose data is equal to that of successor data, right? With this data from the writer subtree of the current root, whatever node is present, just go ahead and try deleting this. That's it. Okay, and I know that the in-order successor resides into the writer subtree of my current root. So writer subtree of the current root may get distorted. It may be that its immediate writer child is the successor. This writer child's address may be updated. So that's why I have just said root dot write equal to that of, after the deletion, whatever may be the address that is going to be returned. And then what I require to do, then what I require to do afterwards. You have just updated the entire current roots scenario. Then what you are required to do, tell.
After the else part, we return root, right?
Yeah. Okay, so I think this else condition may not be required. Am I correct onto that part? Okay, let's keep that. So I can just say return the root. Can I just say whatever may be the change that we have taken, just return that. Or I can just do that afterwards as well, after the all else condition I have handled. Yeah, there's going to be some changes to the root, and afterwards I can straight away say return root. There may be change, there may not be change, just return that at that.
Initially is the successor.
Which one?
146.
What's it, by the way?
It's a node, right? Node successor.
Yeah, so what would happen?
You didn't declare any.
Okay, I am sorry. Yeah, true. It should be node, right? Yeah, correct. Yeah. Anything else that you are missing here? Mostly no, I feel.
Yeah.
Let's try giving a compilation and run. Expected 1, 2, 3, we are getting that as well, right? Let's try running it fully. Yeah, it got submitted. Any problem? Tell me that. Corresponding to that of your node deletion in BST. Any doubts you people have? Tell me that.
Yes, after replace the successor node, why you call again delete node function?
That needs to be deleted, right? You cannot keep same data twice into BST. Am I correct? Suppose that 5 is the node that you wish to delete, and from here 7 started. From here again, suppose there is a, let me say that, let there be 8 here. Let there be 8 here, and from here onwards, suppose there is a 7 and further there is a 6. Correct? I located this 6. Am I correct? I located this 6 and I just said whenever the in-order successor function would be returning this node's value, node's address typically, I'm going to be updating this particular node. 5 needs to be deleted. Now 6 data would be replacing this. Am I correct?
Yeah,
so
right.
After the update, how the tree is looking like? 6, 8, 7, and 6.
7, 6.
Right? So this needs to be deleted.
Yeah, we simply put successor equal to null. Then it will work, right?
But where is it actually? Nobody knows, right? See, for here, you are not considering the case why I'm doing it recursively. See here, it's not that your successor is going to be always a leaf node, right? Suppose that you are having 5 as well here. And what should I
in
say?
that case, successor will be a leaf node, right?
Which one?
Always a leaf node.
Is it that?
Yeah.
You are sure?
Yeah.
Okay, suppose that you're trying to delete 5 and right now you are having something like this 7, 8, 9. Is successor a leaf node here? Is successor a leaf node?
No,
Now
no.
the address of 7 would be returned, right here?
Yeah,
Yes,
yeah,
that's
right,
the
right.
immediate. 7 would be
Yeah.
returned, you would be copying 7 here. Now you would be trying to delete 7 in this case. Am I correct?
Yes,
7
yes,
needs
yes.
to be deleted. Now, if you make a call for deletion of 7, further what would happen? If 7 needs to be deleted, 8 would be replacing 7 into its position. It's in order successor further. Am I correct?
Yeah, yeah, right, right, right.
So there should be a recursive deletion that needs to be taken care of. Okay.
Okay, okay, it's clear.
Because corresponding to a single deletion, there can be multiple other deletion that may be required. Then at the end, when it would be hitting 9, then you can say that null would be returned in those cases. Okay, so this is all about our deletion. Now, if I ask you for a few basic questions of BST, tell me that what is the, if you consider a BST, right? What's gonna be the worst case scenarios of insertion and deletion time complexities? Insertion and deletion time complexities. What's gonna be the worst case scenarios?
It's big of heights, right?
Yeah, in the worst case, what may be the height for us?
Height is the
Number of edges
number
from
of
the
edges.
root
Yeah,
node to
right.
the deepest leaf node. Right? We have
Deepest
discussed
node.
that, I feel. The
Yes,
concept of
yes,
height.
yes, we discussed it.
Okay, so what can be the worst case scenario for this?
Big of heights.
If I just say, is this a BST? 1, 2, sorry, it's not, sorry. Is this a BST? 1, 2, then afterwards 3, then 4, then 5. Tell me that. Is this a BST?
Yeah,
So how many, if you started off from the leaf, from the root, you reach up this 5. And if you insert 6 at the end of 5, right? How many overall traversals I required?
5 traversal.
5. So I think big O of n would be the time complexity in the worst case. If there are existing n nodes, then after traversing all those n nodes, I can insert a particular node. This is the worst case scenario for BST, right? Am I correct?
Yeah. Yeah.
What about the deletion? What about the deletion?
Same big of n.
Okay, same, right? If you wish to delete 6 at the end from 1, 2, I have to locate, traverse all the n nodes, locate 6, then I can try delete. So big O
No,
of n is
suppose 2 is left as subtree of 1. Then we don't iterate 2, right? We
which one?
don't.
No, no. If suppose this node 2, anyhow, its value is 0, let that be. So if it is present into the left subtree, then we don't traverse this. Yeah.
Yeah, so it will be the height of the maximum height of the subtree, right?
Yeah. So
Right.
maximum height would be this scenario when all the nodes are lined up in a particular chain. Okay. When all the nodes are lined up into a particular chain. This is the worst case scenario that you may encounter.
Yeah.
This is what you have to. Big O of height is in general, but in the worst case, the height would be itself big O of n, would be equal to that of n. So you would be saying that big O of n would be the time complexity for both insertion and deletion. What about searching? Searching into a BST. What would be the worst case time complexity?
Same big of n.
Same big O of n, right? All the nodes I would traverse and the last leaf node present would be would be searched off and its result would be returned. Okay, so in terms of BST, right, it's not always height balanced. There is a counterpart of BST, what we call as AVL trees. This is what we call as height balanced counterpart. But there is some overhead. Every time you make an insertion deletion, if the overall height balanced nature is distorted, then we perform some operation on the BST to make it height balanced. Every of the subtree would be height balanced. Okay, this is what you call as AVL trees. So here always in terms of AVL trees, whatever we are having, the insertion deletion, as well as your searching, whatever you may have. In the worst case, due to the maintenance of the tree in terms of height balanced nature, it's always in terms of big O of log n, where n is the number of nodes inside, not more than that. Okay, this is how your AVL trees work. If you want, we can take the insertion, deletion, and height balanced nature of AVL trees going forward. it would take me one class at max, not more than that. So that's it. And anything else that we have missed corresponding to that of BSTs? I think searching and insertion you people can do.
Yeah, we can.
Deletion was the critical part that we have taken. Okay. So the major topics of BSTs I feel is over. Now practice more questions on this. And if you're having any doubt, you may ask.
Yeah, it's your side, all okay. I need to practice a lot.
Yeah, BST is quite a bit, I feel, new topic. So I
Yeah.
think good questions Vishant has
Yeah.
also covered in the
Yeah,
previous
yeah.
two classes.
Yeah,
Lowest common ancestor and everything he has covered, right?
yeah, LCA.
Okay.
LCA covered yesterday. LCA and convert the
BST to height, convert a
array
sorted
into
array to
height balanced
height balanced
BST.
BST, right?
Yeah, yeah. Array and list into a height balanced tree.
Great. Yeah, questions were good, by the way, whatever he has taken. And in the previous class, what was being covered?
I think some kind of BST problem.
Yeah, BST definitely. There is recover BST was a problem he covered, right?
Yeah, yeah, yeah.
Two keys would be misplaced from their position,
Ah.
and how can you try recovering them?
Yes, 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 yes. Exactly.
So yeah, majority of your good BST problems are mostly done. That's what I'm going to be saying. And I think in the previous day, two problems more while introducing BST we have taken. Two problems, I guess. So these are a few problems of BST. Now practice few more questions. I would ask your Amit to add more problems onto your sheet. That's what quite late going on. That's what I have seen. And let's do one thing. Let's do from the next day your start heaps. Vishant is going to take your class for the heaps introduction. 1-2 class are sufficient, and afterwards we'll move on to next topic. Once BST is one, your heaps are over.
Yeah.
Okay. And at the end, we can take one class on your AVL trees, or if possible, in the next week only, let's take AVL trees and let's see how to maintain the height balance nature of BSTs. That's what we may try doing. But that's quite theoretical. Okay. Not everyone is going to ask you that.
Yeah, right.
Okay. So I think